Hello and welcome to another in our series of Maths by the Sea. In this episode we're looking at question 4 from Pure Maths 1 October-November 2024 of Cambridge AS Maths. And we have to show that the curve with the equation x squared minus 3xy minus 40 and the line with the equation 3x plus y plus k equals 0 meet for all values of the constant k. To find out where curves and lines intersect, we simply have to solve the simultaneous equations. In this case, the easiest way is by substitution. Now we know that 3x plus y plus k equals 0 from up here, and this implies that y is equal to minus 3x minus k. Note this little symbol here means implies, the little arrow. Substituting in the equation for the curve, which is here, we have this equation here, the y is equal to minus 3x minus k. This equation simplifies to here by simple expansion of the bracket. We get x squared plus 9x squared plus 3xk minus 40 equals 0. Simplifying that, x squared plus 9x squared is 10x squared, so we end up with this equation here. Now you should know that the discriminant of the general equation ax squared plus bx plus c equals 0 is b squared minus 4ac. You need to put this into your question answer book and learn for the exam. Question on one side, answer on the other. In our case, we've got b squared minus 4ac equals this, because little b is the coefficient of x squared, which in our case is 3k, and little a is the 10 from here, and little c is minus 40 from here. So bx squared minus 4ac is equal to 3k squared, all squared, minus 4 times 10 times minus 40, and that simplifies to 9x squared plus 1600. Now k squared is greater than 0 or equal to 0 for all real values of k. For example, if k is 2, k squared will be 4, greater than 0. If k is minus 2, k squared is also 4, still greater than 0. So the least value of k squared will be 0, which occurs when x equals k. So because k squared is greater than or equal to 0, that tells us that k squared plus 1600 is even bigger. So it's always in fact greater than 0. It can't be 0 anymore, because if that's 0, now you've got 1600. So therefore the curve and the line will meet for all values of the constant k, because if your discriminant is greater than 0, that means you've got two distinct, i.e. unequal real roots. You also need to learn about more discriminants. So the discriminant equals 0, it means you have two equal real roots. If the discriminant is less than 0, you have no real roots. If it's greater than or equal to 0, you've got one or two real roots, but in any case they're real. Please note that roots means solutions, real means not imaginary. For example, the square root of minus 1, because you can't find the square root of minus 1 as a real number. You'll learn more about imaginary numbers next year. Please put these into your question answer and learn for the exam. It's been wonderful having you here, and hope to see you next time in our next question in the series. Bye bye.